Math, and today we are going to tackle about heap sort. Heap sort. So what is a heap sort? A heap sort is a special type of binary tree in which the value of each node is greater than the value of each leaf. A heap sort algorithm works first by organizing a list of data into a heap. So, a heap should possess or should maintain the following properties. Number one property is it should be a complete binary tree because a heap sort is a binary tree and it should be a complete binary tree in which the heap data structure is always a complete binary tree, which means all levels of the tree are fully filled. For example, in this example, if this is your array and we are going to form it into binary tree, as you can see, it is a complete binary tree. This is a complete binary tree because all levels are completely filled. Well, in the second example, if this is your array, as you can notice, there is a missing element between. So this will make your binary tree an incomplete binary tree because there is a missing element here. And this will not be considered as a heap sort if you have an incomplete binary tree. Again, the first property of the special heap should be a complete binary tree. Go. The second property, it should be a max heap or min heap. Max heap or min heap is the two types of heap, and it should be maintained in creating a heap. All nodes are either greater than or equal to or less than or equal to each children. So if parent node is greater than the children node, it is called max heap. While if parent node is less than the children node, it is called min heap. For example, if this is your binary tree and this is your array, your parent node will be this. And the children of this parent node will be 9 and 8 since it is below the parent node 10. And then, this will also be considered as a parent node because there will be a children below it, which is the 7 and 5. And here, 4 and 3. And again, if it is a max heap, the rule of max heap is that the parent node should be greater than always to the children node. If this is your parent node, this is correct because 10 is greater than its children node, which is 9 and 8. And this is also correct because 9 is greater than its children node, which is 7 and 5, and 8 is greater than 4 or 3. Again, if max heap, all parent nodes should be greater than its children node. The next type of heap is the min heap, wherein parents should be less than its children. For example, if your parent node is 3, then the children should be greater than the parent node. For example, 4 and 5 is greater than the parent node 3. So this is a min heap. Well, the 7 and 8 is greater than the parent node 4. So this is a min heap also. While 9 and 10 is greater than 5. So it will follow the property of min heap. So this will be the array for your min heap, the 3, 4, 5, 7, 9, 8. So as you can see, lower number starts, then the ending is the greater number. The formula, there will be a formulas in creating a heap sort, and this will be also seen in your Java programming. If your left child, 2 times the index number plus 1. So if you're going to look for the left child of the parent node, so you will just use this formula if you don't know how to arrange this array. And in the right child, you're just going to 2 times the number of index plus 2. And then if you're going to find the parent node of the children node, is just 1 divided by 2. For example, if your first array is 10, we all know that 10 is in the index 0. So all you need to do is to find who will be the left child of your index 0, which is 10. So you are going to use this formula. So 2 times 0 is 0 plus 1 is 1. So the left children of 0 will be index number 1. The index number 1 is 9, so here. So the left child of the parent node 10 will be index 1, which is 9. Also, it's the same with 8. If you're going to find the right child of number 10, you're just going to substitute this using this formula. So 2 times 0 will be 0 plus 2 equals 2. So index 2 will be the right child of your parent node 10. And you can also use this in others. So if you're going also to find who will be the parent node of that child node, for example, you're going to find the parent node of 2. So you're just going to substitute the index 2 here. So 2 divided by 2 will be 0. So the 0 index will be the parent node of your children, the right children 8. So that is 10. Next, I am also to clear about the formula in making the heap sort, because this will be used in your Java program. So if you're going to find the left child of your array number 0, if you're going to find the left child, you will use this formula. So 2 times, since 10, the index number of 10 is 0, so you're just going to substitute 0 here, plus 1. So 2 times 0 is 0, because any number that is being multiplied into 0 is 0. Plus 2 equals 1. So this means that array 1 will be the left child of your 10. So 10 and the left child is 9. Is 9, and also with 8. So if you're going to find the right child of your array or your index 0, so you're just going to do this formula. 2 times 0 plus 2. So any number that is multiplied by 2 is 0 plus 2 plus 2. So index number 2 will be your right child. And this formula can be also used with this. So if you're going to find the left child of index number 1, so you're just going to substitute 1 here. So 2 times 1 is 2 plus 1 is 3. So the left child of 9 will be 5. Next, after knowing what is heap sort, we should also consider this one, the heapify. So what is heapify? Heapify is to rearrange a heap to maintain the heap property. Again, we all know that heap property, it should be a complete binary tree or either a max heap or min heap, depending on what you want to see in your heap sort, if it is a max heap or min heap. So the heapify will maintain your heap property, that the key of the root node should be greater than or less than its children. If the root is not greater than or less than its children, then swapping is needed. So the heapify will swap the nodes if it will not follow the property of the heap. Now, we are going to tackle on how to make a heap sort. In making a heap sort, you should follow this step. First is you must create a heap, and number 2 is you must delete all the elements in the heap. So once you delete the heap in the heap that you have created, it will be considered as sorted. Again, if you will delete the element from the heap, it will be considered as sorted already. Next, I also have here a visual presentation in order for you to clearly understand the idea of heap sort. Again, in creating a heap sort, first, you must create a heap that will follow the 2 properties, which is a complete binary tree and either a max heap or min heap. Second is that you must delete the elements, all the elements, to consider it as sorted. So, the first step, we must create a heap. For example, this will be our array, 10, 20, 15, 30, and 40. So one by one, we will put it in our binary tree. So the first element will be 10, and 10 will be considered as our root node now since it is in the first part of the array. So 10 is already removed here and already put it here in the binary tree. So next element in the binary tree will be 20. So 20 will be put in here, and 20 will be considered as the left child of your parent node 10. As you can see that this is a complete binary tree, but then this is not a max heap since 10 is greater than 20, right? So all we need to do is to do heapify. We are going to adjust the elements to consider it as max heap. So we are just going to substitute 10 to 20. Remove 10, put it here, and put 20 above. So now, our root node will be 20 and the left child will be 10. After putting 10 and 20, we are now going to put into the binary tree our number 15. So, 20, the left child will be 10 and the right child will be 15. So, this follows the idea of heap wherein this is a complete binary tree and also 20 is greater than its left child and right child. So this is correct. No more need to adjust the elements. So after putting 10, 20, 15, we are now going to put number 30 at the left child of the parent node 10. So this is a complete binary tree, but the problem is this is not a max heap. So all we need to do again is to do heapify or adjust the elements. So if you're going to put 30 here, it will not still follow the idea of max heap because 30 is greater than 20. So we are going to put 30 at the root node. So remove 20, put it here, and 20 to be placed here at the left child of 30, and then 10 will be here. So we already adjust the elements 30, 20, 10, and 15. So we are going to change now the elements in our array so that we will not be confused. So the 10 will be now put here and substitute with 30. So 15 will only remain there because we did not move it. So 30 followed by 20 and 10 will be here. Because 10 is not your third element in your array, so it will not be considered be placed here because 10 is in number 3 array. Next, after putting 30, 20, 15, and 10, we already follow the idea of the heap properties. So next we will put 40, which will be our last element. So I only give 5 values in our array so that it will be easier for us to understand the idea of the heap sort. So this will be our binary tree wherein 30, 20, 15, 10, and 40. Again, this is the complete binary tree but not a max heap. So all we need to do is to adjust the element. We have to substitute 40 to 20, and again 40 is greater than 30, so 40 should be placed here. So remove this, then bring it down. Then 40 will be our root node. So we have to adjust all the elements except for number 15. So 40 will be our first element, followed by 30, then followed by number 10, and last is number 20. So that is the first step, which is to create the heap and follow the max heap. Next is to do the idea of deleting elements. Again, to delete the elements, we must delete first the root and change it with the last element. So this will be our first element and change it with number 20. And the deleted element should be placed in the sorted area of your array. For example, if our root here is 40 and our last element is 20, so we are going to delete this one. So this will be already deleted, and 20 will be replaced or substitute, and it will be considered as your root. So if 40 will be deleted in your array, so it will be considered black because black represents that the array is already deleted. So we will substitute 20 here. And then 40, since it is already deleted, so we will put it here, and this line will be considered as the sorted area of your array because it was already deleted. Yeah, so this is already the deleted portion. Again, deleted portion will be considered already sorted. So 40. Again, as you can see in your binary tree, this doesn't follow the idea of max heap. So since 20 is greater than 30 than 15, all you need to do is to heapify or adjust the elements. So remove 20 and put it here. And also in your array, so that you will not be confused, you will also adjust this to and put it here. So this will be your array now, 30, 20, 15, and 10, which follows a complete binary tree and a max heap. So since 30 will be now your root node, so all you have to do is to delete again this one and place it in the sorted part of your array. So delete number 30 and change it with the last element, which is 10. So we already have 10, 20, and 15, and we will remove 30, and the black box will be considered as deleted. So we will put it here, and 30 will be placed here, which is the deleted portion of your heap sort. So this is the part which is already deleted and sorted. Next is, this is not a max heap. So again, we need to adjust the elements. Put 20 here and put 10 here. And adjust also in your array so that you will not be confused. So you just need to put 20 here since it is the first element in your root node, because root node always comes at the first part of your array or the index 0. 20. So 20, 10, and 15. So since 20 now will be your root node, this will be deleted to be considered as sorted. So we will remove 10 and change it with the last element, which is 15. So delete 20. So 20 will be now in the color black box to be considered it as sorted, and 15 will be put at the first element or at the index 0. So we will also adjust the deleted portion of our array. So since 15 and 10 is the remaining elements in our heap sort, and this is already a complete binary tree and also follows the max heap because 15 is greater than 10, right? So you don't need to adjust the elements. So all you need to do is to delete the root node, which is 15, and substitute it with the remaining element or the last element, which is 10. So 15 is removed and being put in the deleted portion of your array. Then after, since 10 is the last element, you just have to remove this one, and this will be considered as sorted. Now, all the numbers or all the values in your array are already deleted and it is already sorted. Before I end, I just want to remind you that before creating your Java program, it is important for you to understand first the idea as what I have to today. So I have first tackled to you the idea of heap sort. So in heap sort, you must maintain the properties of heap sort, which is it should be a complete binary tree, and second, it should follow the max heap or min heap. And also, in creating your heap sort, first you must create the heap. Next is you must delete the heap to be considered it as sorted.